All right. This is 2020, 2020 technical drawing past question for SA2, and now we want to look at the question three. Let's see the solution to question three. And the question three says figure 2 shows a cycle with link OP attached to it. The cycle rolls along KS without slipping. 1. Plot the locus of the point when the cycle makes one revolution. 2. Name the curve produced. Alright, now this is the rolling cycle. Then now this is a point outside the rolling cycle. And to generate other locus point, now we are going to draw another cycle which we will call the generating cycle, that has 35 radius. And now this is a cycloid, a type of a cycloid which we refer to as trochoid. Now, as a trochoid, we have both the superior and the inferior trochoid. Now, when we finish drawing this one, I believe we will all see the type of trochoid it is. And for other type of trochoid, I think I will also do that now. After this, I will also do that. Then we can see the difference between the two type and how to draw the two type of trochoid. So now, here is the solution to this one. Here, this is the solution to it, to that question. This is the solution, and as we can see from point P, this is point P, then it traces its locus round like this and comes back here. This is it's a full revolution, and once it starts here again, it begins another revolution again. It moves like that and on and on. So, and this is the direction of the rolling cycle. This direction, this is the baseline. This KS, this line KS is the baseline upon which this rolling cycle is rolling. So, all right, let's get our drawing materials close, and let's start. Let's see how we can draw this. Thanks. Now, the first thing is to draw the from the question. Produce the question given. Now is draw the line, the baseline KS. Draw the baseline KS upon which the cycle is rolling. We have these are baseline KS. Then on it, let's draw the cycle with radius. On it, we will draw the cycle with radius 25, and also draw the second cycle radius 35. So my compass. All right, now after that, we draw the rolling cycle on the line KS. First of all, let's produce a diameter. And the radius of the rolling cycle is 25. Let's measure our rolling cycle. We're measuring the rolling cycle radius 25. 25. or sometimes we might also. Now when you are doing, in order to have a network, once you use your compass, you draw once, it should be okay. But I am darking my own up for the father. I want it to be more visible, clear, and legible on the camera. So now this is the radius for the rolling cycle. Then the second cycle, we draw the second cycle that generates the locus of the point P, which is 35 radius. So we measure our 35 radius from the question. As we can see, there's a cycle that generates this. The cycle radius to the center of this rolling cycle is 35. So we draw another cycle um, with 35 radius and locate the point P on it. So we measure at the radius 35. All right. Okay. And put it here. All right. And that is it. And this is the point P. These are the. All right. This is the point P. Point P. And after that, we'll draw the dividing concentric circle into 12 equal parts. Now we'll divide this cycle, that is, now this is a concentric circle having the same center. Now, but different radius. We'll divide it into 12 equal parts. 12 equal parts. So we'll employ our 30 by 60 set square. Divide this into 12 equal parts. So put your. All right, that's it. Now the next thing to do is having divided the having divide the circle, the concentric circle, into 12 equal parts. Then take the dimension of one point to the other, from one point to the other, the dimension of it, and that is lay out the circumference of the rolling cycle on the base line on this ks. Lay out the what, the circumference, that is, and if you can see that the circumference is equals to the what, to 12 times the dimension of one point to the other. That is, let's take the dimension of this point to this point, then we'll do it, use it to cut the baseline 12 times, then that equals the circumference of the circle. Let me even count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Exactly, it's 12. Let me confirm my point that I've picked. If it's equal in another part, it's also equal. So now I haven't done it. Then draw a vertical line to pass through this division on this baseline. A vertical line to pass through this division on the baseline. So can take out in the last one. So I haven't laid out the circumference of the rolling cycle on the baseline. Then we've drawn vertical line to divide it into 12 equal parts on baseline ks. Now the next thing is to draw horizontal line from the division on generating circle to the vertical line. And this is the generating circle. This is the rolling cycle. Generating circle, rolling cycle. So we're asked to now project line from the actual of the generating cycle. So here we go. Okay. All right. That's one. Okay. All right. Now, at this point, I haven't drawn the horizontal line meeting the vertical lines. Next thing is to label the center line at each cut of the vertical line. Let's label it. Now, from here, when it touches this line, we call this vertical line, let's call it C1. That is center 1, center 2, center 3, center 4, center 5, center 6, center 7, center 8, center 9, 10, center 11, and center 12. I mean these points, this part, yeah. All right. So now, having looked at these centers, then we extend our compass to the radius of the generating cycle, the radius, which is 35. Then we put it at the center and mark each line. Now, this line here, let's refer it to as line 0 and line 12. This line is 1, this line is 2, line 3, line 4, line 5, 6, 7, 8, 9, 10, 11. Sorry, 7, 8, 9, 10, 11. Yeah, not yet. That's the baseline. This is the baseline. So there's no number allocated to it. So this is 11. This is 11. And this is 10 and 12 back here. So now, so when we put it at center 1, we'll mark the horizontal line for 1. I haven't done that initially, so I'm doing it now. So now, after taking your compass to radius of the generating cycle, the one that generates the point here. Now it has generated the point at 0. Now we'll take it to center 1 with the radius of the generating cycle. Mark line 1. So that's another point. Now let me confirm this again. Okay. Now put it at center 1. Mark line 1. That's the horizontal line. Put it at center 2. Mark line 2. This is line 2. Put it at center 3. Mark line 3. At center 4. Mark line 4. Can you see? At center 5. Mark line 5. At center 6. Mark line 6. At center 7. It's coming down to mark. This is line 7. You can see the line passed through 5 and 7. Then at center 8. Center 9. Center 10. Center 11. Sorry, 11 is coming here. Please always note that This one here is the generating, I mean the baseline. So I'm fond of, okay, I believe I'm not. Okay, 12 now is coming to this point. Can you see? It's coming to 0. So at this point now, you pick those points where it's touching the horizontal, it's touching it here, the center, touching it here, 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 here. Now once you locate those points clearly, then get your French curve or flexible curve to join it. Now I'm going to teach you a perfect way of doing it using your French curve. Now I haven't done that. Get the French curve. Alright, with the French curve, we are going to do, now make sure you are always having an handkerchief with you where you will be cleaning your instrument at every instant to prevent it from staining your paper and your board. And for the particles of your erasers, also use your duster or you blow it away. Alright, so now to join this point using the French curve, set your French curve to at least 3 points. That is, set the French curve that it will be combining 3 points together, that it will be touching 3 points. So once you set it like that, then as you can see, until you get a very perfect, once it joins 3 points, okay, I think I got it here, then join together, then use that same side for this other side too. Use it for this other side. As you can see, good. Once you've done that, then pick another 3 again, another 3. As you can see, from here now, from here to this one, it walk like this, another 3. Good. Then take that side also again to this side, take it to this side to pick another perfect 3. You can see, right? I'm getting it. Yeah. Okay, good. Good, good. All right. Then you come back to this side again, pick another 3. Sometimes it's possible you try on this ones also. Sometimes you can, even this can also work with this. Sometimes you try other part. Okay, let's see this. Okay, this is okay. Okay, okay. As you can see, oh, it works good. Good. Then bring it to this side also. From here, here, here. Good. Can we see it? Very good. So here is the curve. This is the curve, and this curve produced is called superior trochoid. Superior trochoid. Superior trochoid. Then we can clean some parts, those extended vertical line, to make our work neat. And the so also clean this side also to make the work neat. Good. Then use your duster to dust it. And here is the work, the solution to the question 3 from waec, the superior trochoid. And from here to here is this line to this line is the circumference of the rolling cycle. And that is all. Thank you. Let's move to question 3b. Alright, please take note that the rolling cycle is rolling towards this direction. So you can indicate it on the baseline that this is the direction. Yeah.